So these two situations with radical functions are really very different from the previous polynomial and rational functions. Very different. Okay. So what do we always do with the square root? Forget about the limit for a moment. If I look at this function, I see f of x equals the square root of x squared minus 16. And remember, we always have to worry about the domain of this function. So let's find the domain, see what it is. Can anyone give us the condition that I have to write for this function? Just the condition first, and then we have to solve it.
Make it greater than or equal to 0.
Yes, but what? This is very important.
Square root of...
No, the square root is always positive. So this is the square root of x. We never have to write this. This is never needed. The square root is always a positive number. So no need. What do I have to write that has to be greater than or equal to 0?
Just x.
I don't take the square root from x. The square root is taken from this quantity. I cannot separate anything from there. Anyone?
Is it instead of going to be x negative 4 in the brackets, then x?
I need to write the inequality. Don't solve anything. I need everyone to see how we start.
X squared minus 16.
Yes. So thank you so much. Who was that?
Levi.
Levi. Thank you. So please remember, we had a function like this at least 4 times already this semester. I'm going to count moving forward. For some reason, no one likes the square root. I don't know why, but no one likes the square root. So this is probably the 5th time that we're discussing this. Let's write it again. The square root can be taken from positive numbers and 0. The square root cannot be taken from negative numbers. This answer is not real. We never write that the square root is greater than or equal to 0 because there is no need. This is known. This is known to be a fact. What we don't know is whether this quantity is greater than or equal to 0 to make the square root real, a real number. So please remember, it's not difficult. Under the square root, whatever we have, you have to state this condition. Okay, now the question is, this is not easy. How do I solve a quadratic inequality? That is difficult. Not difficult, but it requires some thinking, right? So no, we cannot write this and take square roots. Not allowed. Not possible. How we solve a quadratic inequality is by finding the solutions, in this case, by factoring. So I have x squared minus 16 greater than or equal to 0. How do I factor this?
X plus 4, x minus 4.
Brilliant. Thank you very much, Rakita. Very good. Now, we have several options here. I'm going to show the option that I like the most. You may say, nope, I don't like this. Too much writing. Fine. You can use a different method. But I would like to show you the one I like the most. And here it is. X is the variable in the problem. And the variable in the problem can be anything. The first factor is x plus 4. The second factor is x minus 4. I don't care about this. I don't care about this. I care about this. I care about the product. Okay, so then my last row would be the product. My next step is to find the solutions. What solutions am I talking about? Imagine that you are setting this equal to 0. What solutions will you get? I'm not changing the inequality into an equation. I need the solutions though. So can anyone give us these in? Yes.
4 and -4.
4 and -4. Awesome. I'm going to put these numbers in ascending order for x. So under -4, what will I write for x plus 4?
0.
Of course. Brilliant. Under 4, what will I write for x minus 4?
0.
Excellent. Under -4, what will I write for the product? Under +4, what will I write for the product? If any of these is 0, what will the product equal to?
0.
Of course, no question about it. So let's analyze x plus 4. Before it would be 0, plug in a number and give me the sign. I don't need any calculations, just the sign.
Negative.
Negative, because if you plug in -10, -10 plus 4 would be a negative number. Plug in any number to the right-hand side of -4 or to the right-hand side of its 0, any number, and give me the sign, just the sign.
Positive.
Excellent. See, the pattern will be the same because both have a positive slope. So let's check. Plug in a number to the left of 4 here.
Positive.
Let's try. If I plug in -10, -10 minus 4 will be -14. So what sign do I put?
Negative.
Yes, because it's the same thing. It's a linear function with a positive slope. It comes from negative, it crosses the x-axis, and it goes positive. Now, if the slope is negative, if the slope is negative, it will come from positive and go negative. But the slope is positive. It comes from negative numbers and goes to positive numbers, no matter what. Now, I don't care about this, I don't care about this, I care about this. If I multiply two negative numbers, what type of number will I get? Good. If I multiply a positive by a negative, good. And if I multiply two positives,
Positive.
good. Now, stay with me. What sign for the product? What sign will I pick according to this symbol?
Positive.
Yeah, perfect. So here's the positive sign. For which x values then? The product is positive for which x values?
From -infinity to -4, and then 4 to infinity.
-infinity, -4. I will close and keep 0 because of the equal symbol. Union for infinity. That's it. So only now, yes, any questions? Any questions? So now, finally, I can give an answer for my limit. Notice that we haven't even talked about the limit. All I talked about was how to find the domain of this. We wrote the condition, and we found, we talked about what's happening here. This is really not part of the problem. I was just refreshing your memory. Then I realized that this is a quadratic inequality. Then I realized that I cannot separate the terms in a quadratic inequality. That's not allowed. It's not allowed like in an equation it is. In an equation, yes, but in an inequality, no. I factored, I studied the sign. In this table, I studied the sign of each factor because I wanted to study the sign of the product. I don't care about these, but I had no choice. I had to study the sign of these two in order to find the sign of the quadratic expression. Also, you can say, wait a minute, you could have graphed it. You know how to graph x squared minus 16. So this is x squared, and this is x squared minus 16. It's very clear that it's negative between -4 and 4. And the function is positive from -infinity to -4 and 4 to infinity. Fine, acceptable. That's fine. You can do that. As I said, I wanted to show you my long method, which I think is very clear, but you may say, no, I prefer to graph. Fine. That's another option. And there is another, of course. Okay, so now let's discuss the limit and finalize this. That's why the domain was extremely important. So the limit of this, which is the trend of this function, when x approaches -4 from the left, is -4 from the left in the domain? Because if -4 from the left is not in the domain, then I will write DNE. If -4 is in the domain, then I will have to write something else. So, is -4 from the left?
Yes.
Yes. Please plug it in then. You are allowed to. Thank you, Sierra. You are allowed to plug it in and give me the answer.
0.
That's it. Awesome. Great job. Exactly. What if I change the problem? This is another problem or another question. Here it is for our problem here. Connected. X approaches -4 from the right of the square root of x squared minus 16. What would you say?
Does not exist.
Yes. And the question is why? Because -4 from the right is in the empty area, is when the radicand is negative. I cannot take a square root from a negative radicand. So that's why it's DNE. Final question here. This is another one. What about the limit as x approaches -4 from either side, not left, not right, from either side simultaneously, from x squared minus 16? What will you say?
Does not exist.
Of course. Can anyone tell us why?
There's no point from the left or the right.
Absolutely. Yes. So the limits from either side have to exist. If one of them exists and the other one does not, the limit from either side will not exist. Exactly. See, that's why I kept my previous lesson here. Handy. Good. Awesome. Okay, so let's discuss continuity. Oh, that's my page 3. Oh, how am I with time here? Good. Okay, continuity. And the question is why? Why do I care? And you'll see in the next section why we care. And I'll tell you why we care anyway. I'll write it down. Okay, so what is continuity? Is this function continuous?
No.
No. So this is called the jump discontinuity. It's a jump. See, I graphed, I ended here, I took my marker off the paper, and I continued here. So this is not a continuous function. Here's another one. Is this a continuous function? Before you say anything, watch me graph it. Is it a continuous function?
No.
No.
It's a jump.
No, this is called infinite discontinuity. What about this function? Follow closely. Is this function continuous?
No.
No. This is called removable discontinuity. So finally, here's a question. Is this function continuous?
Yes.
Continuous function. Yes, this is a continuous function. This is not continuous. This is not continuous. This is not continuous. Okay, so why do we really need to talk about continuity? And I want to talk about continuity at a point. That's very important. So why? Here's why. Why do we need to talk about continuity? Because at this point, for example, when x, let's say, is 2, see, there is a tangent here, and there is another tangent here. So at x equals 2, the function does not have a unique tangent, one tangent. Here's a by comparison. At this point, there is only one tangent. Unique, only one tangent. Who cares? Because in calculus, we are talking about motion, right? So the slope of this tangent line will give us the instantaneous rate of change of the function at this point. So this is the reason why we are interested to know if the function is continuous or not. Okay, so there are problems with continuous functions as well. I'll explain. But in this case, the function is continuous at this point, and it has a unique tangent, which means I can determine the instantaneous rate of change. This is what we are interested in this class. The instantaneous rate of change. How fast is the function changing here? Or here, because there is only one tangent. Here, because the function is not continuous, At this point, the function does not have a tangent. It doesn't, at this point, no instantaneous rate of change. None. At this point, yes. I can determine it. At this point, yes, because there is only one tangent. But here, when the function is not continuous, no instantaneous rate of change. Same here. 2 rates of change. No, that's not possible. I can't have at this point 2 rates of change. So that's why I don't have a unique rate of change. And here again, the same thing. When the function is not continuous, there is no unique rate of change, no unique tangent. Okay, enough of that. And now I'm preparing you for the next step. So finally, one definition is very important here. Continuity at the point. What is that, continuity at a point? I'm checking the time.